Welcome, Calculus AB. This is lesson 2-3, infinite limits and limits at infinity. Let's begin. So let's talk about infinite limits here. So you've seen some examples I got right here. You've seen examples where the limit does not exist. So like when we did direct substitution, you got to points where the limit of some function, as you plugged in like 5 of like 1 over x minus 5 equals 1 over 0. We say the limit does not exist. And it does not exist because you have this thing called an asymptote going on here. So an asymptote is like a line, an imaginary line that the graph approaches and gets really close to, but never touches. So in these cases where we do not exist, we actually have vertical asymptotes. And here's like 4 examples of what that could look like in a function. So what we can actually do, instead of just saying does not exist in these cases, we can actually express these as infinite limits. Like it's doing something. So we can say it's going up to positive infinity or going down to negative infinity. And this is how we write this. So the limit as you approach some c might be positive infinity, or limit you might be in negative infinity. So if I'm taking these cases right here, you can see when this side of the graph it's going up to positive infinity, and this one's also going up to positive. Sometimes you have cases where both the left and right side go down to negative infinity. Sometimes you have cases where they're different. So the left side is negative infinity and the right side's positive, or sometimes it might be opposite. Left side's positive and right side is negative infinity. So you're going to have cases that look like this, and we might want to identify like, is it going to positive infinity or is it going to negative infinity? So we're going to talk about how to figure that out. So a few examples, and basically the reason you're going to have to check infinite limits, where if you do direct substitution, so you just plug in that number in, it results in an undefined limit. So like a number like 1 divided by 0 or 5 divided by 0. It's a number that's non-zero divided by 0. 0 divided by 0, as we learned last time, is indeterminate form. That's not going to qualify. So only an undefined limit, does not exist limit. So we want to check if it's going to positive or negative. So how do we do this? So let's take this example right in here with the 2 plus. X plus 3 over x minus 2. And if I plugged in 2, I'd get 5 over 0. Does not exist, so I know it's going to positive or negative infinity. And so your question is, well, how do I figure this out? The easiest way to do this is to plug in values that we have to like plug in values and see if it's going up or going down. You know it's either going to be positive infinity or negative infinity. We just don't know which one. So let's plug in values. And if it's a 2 plus, let's plug in like 2.1, a little bit higher. So we get 2.1 plus 3 over 2.1 minus 2. And what you're really checking for is you're checking to see if the tops and bottoms are negative or positive. And that tells you, like, you could do a bunch of values and plot it going up or down, but you're checking to see if the sign of the top and bottom. And that'll give you an indication. Because if you have positive over a positive, it's going to be positive infinity. But if you have like a negative over a positive or a positive over a negative, it's going to be negative infinity. And if you had negative over negative, dividing two negatives becomes a positive. So in this case, what you're going to have is 5.1 over 0.1, which is a positive over a positive. So I know my limit is going to be positive infinity. Because it's positive. I'm always going to have positive numbers as I'm approaching 2. So it's got to be positive infinity. Let's check the other way. So a negative infinity. So a little bit smaller than 2. So let's go to 1.9. So I'll have 1.9 plus 3 over 1.9 minus 2. When you have that, you get a 4.9 over negative 0.1. So you have a positive over a negative. So positive divided by negative is negative, so I'm going to be at negative infinity. And if you think about this, you're always going to have numbers a little bit less than 2. This bottom's always going to be negative. This top's always going to be positive. So all you have to do is like plug one number and you're fine. We'll save these for class so you can do them at home. Now, let's talk limits at infinity. So what does a graph of x do? So we did as it's a limit going to infinity last time. But what about when your graph goes really far to the negative side or really far to the right, to the positive side? Like, what is it doing? We might want to define that. So we can talk as limits as x approaches an infinity or limits as x approaches negative infinity. What does the graph do? Well, what happens when you go there is we might approach something called a horizontal asymptote. If it's not a number. So let's say I did y equals x squared first. Okay, I want to do that example first. It's a parabola looking like this, right? So if I asked you limit as x approaches infinity of positive x squared, well, as you go to the right forever, it just goes up forever. I would just say my limit is infinity because it's going to keep going up. Same thing as if I approach x is approaching negative infinity for that same thing. As you negative infinity is to the right, it keeps going up, so I'll say it's also positive infinity. All right, but sometimes we'll have graphs that do other things. Like, you might have a graph, and I don't have an equation for it, but you might have graphs that do things like this. We'll see this kind of graph later. Where as you're going to the right forever in this case, let's call this f of x, we're going to say our limit as x approaches positive infinity is approaching some like dotted line here. It's approaching the asymptote, which is on the x-axis. So we can say of this function, it's going to be 0. Because as you go forever, it's just approaching this line, but never touches. I know it does touch here. You can cross these lines, but as you go to infinity, they never touch for horizontal asymptotes. All right, we'll have to show some examples in class, I'm sure. But another part of this, now, let's start applying this a little bit more. So we just try to talk what horizontal asymptotes look like. What's it going to look like when you're actually doing examples for this? So these are typical problems that you might see, where you have like polynomials, like with a fraction, a rational, and you go to infinity. Like, where's it going to go? And for large, so this is where it gets kind of weird. For large values of x, you're always looking at the highest degree terms. Large values, we mean infinity values or negative infinities. You're looking at the highest degree terms. And the reason you are is, let's say we're talking about, I hate doing it that way. Okay, so you had a bunch of equations like x squared, x cubed, right? And then let's plug in different values for x. You plugged in 1, this would be 1. Everything's 1, right? Let's say I plugged in 10. This is 10, this is 100, and this is 1,000. Okay, you see there's a big difference here, right? What if you plugged in 1,000? Well, this becomes 1,000, this becomes 1,000,000, and this becomes 1,000,000,000. This x cubed number, as x goes up, becomes way bigger than this number. And it's still way bigger than this number. But so x goes to really, really big numbers, all that matters is those highest degree terms are going to absolutely destroy everything else. We're to the point where when we're talking limits to infinity, these ones don't matter. Only the highest degree terms matter when we're talking going to infinity. So what we're going to actually do when we're looking at these infinite limits, we're on each, the denominator and numerator, we're only going to look at the highest degree terms. The rest don't matter. Like this plus 2, when x is like 1 billion, who cares? It's just trivial. And even this x squared, it might, if x was 1 billion, yeah, that's a lot of billions, but this is going to be way more. So this doesn't matter either. Same thing on the bottom. This plus 3 doesn't matter. So really, when I was looking at that limit, all I'm looking at is 5x to the fourth over 10x to the fourth when I'm doing that limit. So I'm going to rewrite that. Limit as x approaches infinity of 5x to the fourth over 10x to the fourth. All right, so what's that limit? Well, we can start canceling things out. X to the fourth cancels. So you're left with 5 over 10, which is just 5 over 10, which is 1 over 2. So my limit is actually 1 over 2 for that case. Let's do the other ones. Let's do number 10. It's slightly different over here, right? So again, only things that matter are the highest degree terms. Just cross them out, just like this. So I'm left with 5x to the fourth over 10x to the fifth. Let's reduce things. You can cancel 4 of the x's, so you're left with only 1x in the bottom. And then the 5 over 10 reduces to 1 over 2. So I'm left with 1 over 2x. So I'm looking at my limit as x approaches negative infinity of 1 over 2x. You plug in negative infinity, you get 1 over 2 times negative infinity, which is just negative infinity. Well, constant over any infinity actually goes to 0. Learned that in the last video. Last one. Again, only things that matter are the highest degree terms. So just these two. I can cancel out 3 of the x's with 1 of the x's here. And so you have 5x over 10, which reduces to x over 2. So the limit as x approaches infinity is going to be infinity over 2, which is just infinity. Divide infinity by a half, it's still infinity. So that's how you can do those. All right, skipping that for now. We'll do that in class. Last thing, I want to talk about radicals. So radicals are a little weirder. We're doing the same thing as before. But sometimes we have to like check our limits. So I'm going to cancel out that 3 because it's the highest degree of terms, right? So on the top, I have square root of 4x squared. And we're going to infinity here and negative infinity here. It's the same equation. So we're actually going to get different answers. So square root of 4x squared, well, we can square root of 4 is 2. Square root of x squared is x. That's just 2x over x. And those cancel out. So really, I just have 2 over 1, which means my limit is just 2. Okay, well, this is the same thing, but this limit's also 2, right? Right? They're both 2. Okay, you got to watch something here when we're talking limits. We're talking x is going to positive infinity. And if we have a square root, we know this is always positive. And if this is positive infinity, the bottom's always positive. So 2's fine. But let's look over here. We're going to negative infinity. Square roots are always positive. This bottom is just x is always going to be negative. So my answer, positive divided by negative, it can't be a positive. We're actually going to be going to negative 2. So you have to like check when you're plugging in the infinity, especially with negatives, to make sure your answer makes sense. You might have to like flip the sign. That's it for this lesson.